I would like to give the explain about the valency bond theory. This is the fourth sem student for degree. Topic is the coordination chemistry. Valency bond theory proposed Linus Pauling. This theory to explain structure, kind of bonding, geometry, and magnetic properties. The central metal ion or should accommodated a number of s, p on d atomic orbitals equal to its coordination number. These vacant orbitals hybridized together to form hybrid orbitals which are same in number as the atomic orbitals hybridizing together. So based on coordination number, easily we can find out the molecule or the complex get the which hybridization taking place. So for example, here observe this table based on the coordination number. If the complex having the coordination number 2, the hybridization SP, the geometry is the linear shape. Coordination number 3 and sp2 hybridization trigonal planar shape. Coordination number 4, in the situation coordination number 4, two cases we have to observe here. One is the sp3 tetrahedral shape and one is the dsp2 and sp2d. The complex get this hybridization square planar structure. Based on the ligand nature, these types of hybridization undergoes getting the molecules. Your fifth coordination number, that is the dsp3 hybridization, sp3 dehybridization based on the strong field ligand. So this is the dsp3, a weak field ligand sp3d. Here inner orbital sharing, here outer orbital sharing. So based on the situation of the nature of the ligand, easily we can determination of the which hybridization. So coordination number 5, these hybridizations are happening. So trigonal bipyramidal shape. Based on the coordination number 6, d2 sp3 sp3 d2 octahedral shape. So you have to remember this is the table. So based on the coordination number, easily we can find out the geometry as well as to the hybridization. That point you have to remember. Next point, vacant or hybrid orbitals of metal atom or ion overlap with the field orbitals of ligands to form the sigma bonds. So here what is the vacant hybrid orbitals of a metal atom in ion overlap with the field orbitals of ligands. Metals and ligands overlapping, which bond formation here? Sigma bond formation taking place. Next point we have to see if the extent of overlapping is more greater will be the bond strength is there. If the extension of overlapping is more, overlapping more means that is the bond strength also more. That point you have to remember here. If the metal ion utilizes n-1 d orbitals per hybridization, then the inner d orbitals complexes are formed, which are also known as low spin paired complexes, show diamagnetic in nature. So when the molecule get the utilizing the which orbital n-1 d orbital means inner orbitals forming, that is low spin and spin paired diamagnetic in nature. The metal ion utilizes nd orbitals for the hybridization, then the outer orbital complexes are formed which are known as spin forming or high spin complexes. It show more paramagnetic in nature. If the complex has unpaired electron exhibit the para, does not an unpaired electron exhibit the diamagnetic property. So in the presence of strong field ligands, the electrons are paired off against the Hund's rules. So strong ligands, cyanide, nitrogen, ammonia, ethylene, diene. Weak ligand, fluorine, chlorine, bromine, water molecule and hydroxides. So remember, these are the few important points in the valency bond theory. Simple, overlapping, more strength, and here inner orbital for utilizing, here outer orbital utilizing, inner orbital diamagnetic, outer orbital paramagnetic, strong field ligand, weak field ligand. Strong field ligand means here inner orbital means low spin and spin paired here. This is happening in the, when it is happening, so the complex containing the strong field ligand, this is the situation happening. That point you have to remember. The complex having the weak field ligand, these ligands are present in that complex. In that one, this type of orbital hybridization happening. That point you have to remember. Strong field and weak field here. So weak field ligand means that is the paramagnetic high spin complexes. This is the not spin paired here. Here only spin paired here. So spin free complexes here, spin free here, not a forming the spin free complexes formation or high spin complexes formation. This is the important postulates of VBT theory. So you have to understand, then after you can write down the one by one point. So let us we take the one example and explain that one. Just we have to see here. So what is the structure of here? Structure and bond formation. Hexafluorocobalt 3 chloride here. Hexafluorocobalt 3 ion is the, in the central atom is the, what is the cobalt is there. Cobalt is the 27, that is the 4s2 3d7. So ligand weak field ligand means that is the outer orbital formation. Oxidation state of plus 3 configuration 4s0 3d6 configuration. 27 here 4s2 means 3 configuration means this is the happening. So this is the 27 configuration 4s2 3d7 27, that is the later oxidation number you can write down, that is the 3 electron loses here 2 here 1, total 3d6 configuration here. F3 is a weak field ligand. Metal utilizes the 4d orbital for hybridization and form the 6sp3d2 orbital and octahedral shape. This point you ought to remember. Configuration complex organic 3d, here 4s and 4p here. So here 4d also is there. So how many ligand? 6 ligand we can accommodated the how many 6 vacant orbital we can notate one sp 3 sp s1 orbital p3 d2 orbitals. This is the outer orbital formation. In the case of here nickel, this is a tetra low spin complex. This is the low spin pairing the tetrahedral shape. You have to remember this is the sp3d, not here dsp2 configuration nickel tetra fluoride, that complex formation. So that you have to remember. Only here we are going to discussion one complex. That point you have to remember. One by one we are going to see one. This is the one of the important question for the fourth sem student in the coordination chemistry VBT. What are the postulates you have to remember? First of all, based on the coordination number, easily we can find out the hybridization and the geometry of the molecule. So based on the ligand nature also, one of the exception concept, that point you have to mention and observe when we are going to write down. That is the important point. One by one you can write down, easily will get the full marks.